Hello Tim, here's Daniel. So today we are going to run your parts. I'm back from my trip. Stainless steel, aluminum and steel, 3 gauges, 11, 16 and quarter-inch. They're very similar. We had a little bit of transportation damage here on your 16 gauge cold rolled, so I'm going to straighten that out. We are going to run today with a new media that we have. We call it the purple. It is a ceramic media, price is the same as the other one, which also has some abrasive in the scotch, and it is, the quality of it is that the ceramic is cutting very good, of course, but also they say that the edges are altogether smoother because in a real surface application this abrasive makes one grit finer than it actually is in terms of surface quality, which I find very interesting. So anyway, this is a media that we are using. Should be especially good on your stainless steel, but also on the cold rolled and the aluminum as well, of course. So we will start with the stainless steel, and we'll go from thick to thin. We start with the quarter-inch. Here is the burr side, very good cut, by the way. Congratulations on that. There is not too much here. So we'll show you different speeds. We set the machine fairly aggressively because in the thick materials we can do this. We set it to 48.5, which is heavy for the length of it. That is about 1/8 of an inch plus, maybe a little below the surface. And we set the material thickness, of course, and we will run the stainless. In the beginning we will start with 2 feet a minute, 3 feet a minute, and then 4 feet a minute. Full speed on the cross belt here, and so we turn this on first and then the conveyor, and off we go with the pipe. And by the way, we are going to run the same for efficiency purposes in your overall cycle. I know in a real application you probably want to change belts in between because you don't want to mix the two materials. But here in our demo machine we do that all the time anyway, so we might as well get that. So this is the burr side, that is your burr. And you can see some very, very good results. You should have some good temperature in the part because we are hitting the same part. You see the white line on the part, that's your radius, and you see it around all the contours, including the small contours, and of course on the outside. And even the small holes have some radius to them. So much for the stainless, and we will run that the same way. And then here comes the cold roll. The cold roll, of course, has even more radius because it is faster than the stainless steel. I'm going to reintroduce the stainless. You notice the orientation here because I want to be open to this corner instead of closed here. So here is the cold roll, and this is at 2 feet a minute with a fairly heavy setting. So of course you can always do less if you are interested in less, if this is too much radius for you. If I give you different speeds, you can do less and you'll get very good results. Just set the speed rate and also the brush position to the radius that you want to achieve. On this machine, with the length of the brushes as they are, 51 is very light, 48 is very heavy, and go in between those steps. I apologize, I'm machine operator and cameraman at the same time. So this is 2 feet per minute, and we are going at non-burr side, you have even more radius, but you will not know that. So, this is 2 feet per minute and heavy. We'll go lighter later on, of course, because as the materials get thinner, we will have to ease up a little bit on the brushes so that we don't hit the conveyor too hard. So we continue with the stainless here, with the burr side. Only now we will move up to 3 feet per minute. And we will do the same thing here. And then we will run the last test at 4 feet. Still an excellent day. So we run the other side the same way. But the temperature is already much lower in the part. And you can see that the part progressed a little bit more because we're running quicker. So that was our 3 feet a minute heavy, and the non-burr side here. So, and then we're gonna go with this part here. We are going to go to 4 feet a minute. And I also need to go and catch part of the back here. So that's our steel part at 3 feet a minute. Go on. So here we go. 4 feet per minute, and always heavy. So now you can see already that the radius is smaller, but it still may be very good for the purposes that you are looking for. So, what do we have to do in order to go to the 10 gauge? All we do is we change the material thickness setting to 3. That's how quick you change over. And I can hear the belt just starting to touch here. So I'm just going to back up a tad, not much, 2 tenths. That's all we need. So, now we start with the steel, 11 gauge. And we have our stainless steel here, also with the 11 gauge. That's how quick you change over from one material to the next. Very simple. And of course, in the beginning, we are running 4 feet a minute. The number that you see here is a 3. The machine actually runs, that's just from 1 to 10 for the potentiometer. The machine actually runs about a foot per minute, a foot faster per minute than what you see on the setting. So here, come out with the 2 parts, and again, radius is very good. Smaller, then if we go quicker. Maybe I'll give you a 5 feet per minute actually of those 2 parts and a 2 feet, just so that you can see the comparison. So this is 4 feet per minute. There we go. Stainless here, as well as steel, and that is this. So now, just for giggles, we're gonna go to 5 feet. See what we can get in productivity out of this piece. Again, this is possible because you have an excellent cut. So, to give you an idea of how much speed you can get about 4 parts side by side, and at that speed they disappear in about 8 seconds in the machine. So you can get about 7 parts, 7 times 4, 28 per minute, 28 per minute. Do the math easier, 30 per minute is 1,800 per hour. Take 20% off, it's about 1,400 per hour single side. Way faster than any laser machine could ever cut that. So, but that means that even at slower speed, where you go 2.5 feet per minute, that still would be 700-800 per hour. That still would be a very good productivity. So, and then we do the last one, we're going to go slower, we're going to go back to 3 feet. Here is the hot roll, and here is the stainless. All this is still with a fairly heavy setting. We eased off about 310. Now for the next batch of materials, we're going to ease off more. If you notice that I didn't do the aluminum, because the aluminum can either run faster or can run lighter. And I need to check that we don't have more drop. So that is coming out at 3 feet per minute. 3 feet per minute. Because I don't want to round the aluminum too much, so that we get too much radius that we shear off, especially those narrow strips here. I don't want that. part. So now, set up for 16 gauge, we do this. We go up here to where we are out of the belt. I have it a little bit over 51. Then we go with our thickness to 1.5, 16 gauge, right? And then I'm gonna listen to when I can hear the belt stop. Right there. So that's about 49.4. I don't know if you can see that. So, and then I'm going to give it simply a quarter crank more. So now I can still hear it. I'm still lightly in the belt. That's okay. And we are going to run our stainless first to see what that does at 3 feet a minute. I'm going to turn the camera off for a moment because now I need to straighten out this. Okay, camera goes back on. This goes on, and we're going to run around to the other side. Coming out. And I think you will very, very much like these things. So this is, just for the record again, 3 feet a minute. Waiting for our cold roll to come here. See a little bit of distortion in the leg, but that's going to be bending it. And we go 3 feet a minute, just so that we have that record. We probably could run 5 of those side by side. So at 3 feet a minute, that's 10 seconds, 15 seconds, 17, 18 seconds, call it 20 seconds would be 3 parts per minute. And that's 3 feet per minute. That would be 3 parts per minute, 4 to 5 in a row. Let's call it 4. That would still be 12 times 60. Makes it 720 parts per hour. Extremely productive. So that's the cold roll, that's the stainless. So now we go faster. Why? Because we see it. So here we go. Now we'll go in between. We'll go to 4.5 feet. We'll go to 54 inches a minute. Our stainless, and there's our hot roll. And we do the other side. You can hear those narrow portions go underneath the brush. They were bent up a little bit, so we heard that. Those are the 54 inches a minute. Now, on the thinner stuff, you see that the radius gets a little bit smaller, even though there's no sharpness whatsoever, either in the stainless nor in the hot roll. And the hot roll is here, and the stainless is here. So now we go to we'll go to 6 feet a minute. Start to try it. New purple belt. seems to be doing very well. We are going to be making theoretically 1440 pieces per hour. At some point the operators just can't load it fast enough anymore. So I don't know if you really can just keep on multiplying the numbers. So that takes care of all our cold rolled and our stainless steel. Not that you would mix it because you would change belts in between. So now we are going to the aluminum, and obviously for practical reasons we are going to start with a 16 gauge because that's where we already are. But for the aluminum, we're going to start with a higher speed of 6 feet per minute. But we're also going to make this a lot lighter because the aluminum doesn't need that. I'm going to go to 50 for starters to see how it goes. Now I'm completely out of the belt. So that's 6 feet a minute with a very light setting. And it still gives me good edge rounding, so that's 6 feet per minute. And we are light. I'll run the other side exactly the same way. A small narrow line. I think this is a very well defined part. And with this, I will go one slower at 4. And even a tad lighter. Quarter turn lighter. At 50.5. See what that does. That saves conveyor belt. So that's 4 feet per minute, and it's light, even minus. So very light, but therefore smaller. So now, what we are going to do, we are going to go back to the original, a little bit heavier setting. Still not touching the belt, but we are going to go maximum speed on the machine, about 10 feet per minute. Not even going to bother right on here because you can almost not afford it. These parts, I didn't always note on the same side. So that was the aluminum 60 gauge, and we're going to repeat this exercise for the 1/8 of an inch. Only there is I'm going to go in a little bit heavier, half a millimeter heavier. Why? Oh, way heavier, because I didn't set the material thickness, but you saw that the material still goes through. Whew. So an interesting result. In the beginning you have a lot, you see this, right? Because we were in super heavy, and then towards the end it gets a little bit more reasonable. So let me note that on the part. So this was very heavy. And this was here, this was medium. Okay, but you can see that the material thickness setting on the machine is not super critical. So we are still at 10 feet a minute, maxed out, and we are at 49.5, which the number means nothing because it depends on how long your blocks are, of course. Right? That's 10 feet a minute medium. And then I'm gonna give you, and with that you still feel a little bit of sharpness in some of the edges. So 10 feet per minute medium. That's what I intended to do. So now I'm gonna go a little bit slower, and therefore also the slider. I'm going to go back to 50. And we are running at 7 feet. So that's 7 feet a minute and a little bit lighter. And that very same setting, we're gonna do only at 4 feet a minute. So that was that. Apologize for the finger. In the screen. So, 4 feet a minute, also a light setting in the middle. On this side we have a little bit of dross. We need to make sure that we remove that. So 4 feet is a very good setting for that. We have a little bit of a laser weld splash on this part that you see right here. That's of course in the surface, and the machine cannot remove that. So that's a little issue with your cut there. So that was 4 feet per minute and very light. Sorry. So it could be that you need to set it a little bit heavier to remove that, but again, if it's on the surface, you could run into trouble with that. So that was 4 feet per minute light. And to end this whole thing is, at last we have our aluminum 1/4 inch. So all we're going to do is we're going to set the machine to 1/4 inch. And run the brass side first. On the 1/4, I'm going to go heavier. I'm going to go in a 1/2 millimeter more just so that you see what that is at 4 feet a minute. That may be a little bit more than you want. At point, go lighter, go faster. Yeah, I like that on the 1/4 inch from the burn. Not bad at all. It almost be a little bit more, but 1/4 inch does have a little bit of drop. Actually, we may, on the next run, we may go at 4 feet a minute, we may go a little heavier. At 1/4 inch, you can do that because you won't be touching the conveyor belt. So, I'm going to go in, this is the burn side, I'm going to go in another 1/2 millimeter. You can hear it here, we're at 49 right now. So, that's 4 feet a minute medium plus. You notice that I don't cut my videos so that you can see what's actually going on, or I don't cut them much at least. Sometimes, like you say, you have to straighten out parts and you need to put the camera down, but I try to do this as much as I can all in one piece, and I'm just thinking about what I'm going to do with that last one. Should I go slower or faster? I think I will go heavier and faster, just to show you that as well. So that was 4 feet medium plus. So now I will go even heavier. I'll go back to the 48, but I will go to 8 feet a minute. Let's see what that is. Still not in the conveyor belt. That's actually a nice result. I think you will like those edges when you get them done. No? I need to correct myself. This is the burn side going through now. So this was the burn side. You can see that from the side of the laser cutter. I'm just going to turn the machine off. It's a one button thing. Turn the machine off. So this was 7 feet per minute, heavy, and this was the burr side. We have some temperature in the part when we go heavy. And this here is actually the non-burr side. Okay, and that concludes our business here. I will pack those up again and send them back to you. Thank you very much.